In this presentation, we will learn why a limiting quantity of a reactant affects the amount of product it's possible to obtain in terms of amounts in moles or masses in grams. So we will investigate what is a limiting reactant. In most cases, when we carry out a reaction in experiments, we don't use the exact amounts of reactants as predicted in the balanced equation. One of the reactants will be in excess. Let's take an example. If we add a magnesium ribbon to dilute hydrochloric acid, hydrogen gas will be given off and we will observe bubbles rising from the magnesium. So here we have dilute hydrochloric acid and we will add this magnesium ribbon. Hydrogen gas will be produced. When this reaction stops, so when no more bubbles of gas appear and when the volume of the gas produced over here remains unchanged, this means that the reaction is over. However, we can see that there's still magnesium ribbon. So the magnesium in this case is in excess. So why did the reaction stop if we still have magnesium ribbon? The reaction has stopped because all the acid has been used up. So in this case, the acid HCl is the limiting reactant. So the reactant that gets used up first in a reaction is called the limiting reactant or the limiting reagent. Let's take an example now to learn how to identify which of the reactants is the limiting reactant. If we have 4.80 grams of magnesium ribbon reacting in a solution of dilute hydrochloric acid containing 7.3 grams of HCl, which reactant is the limiting reactant? We are given the relative atomic masses of magnesium, hydrogen, and chlorine. First of all, you have to always start with writing the chemical equation for this reaction. Here we have the balanced chemical equation. So in order to determine which reactant is the limiting reactant, you have to write the balanced chemical equation. Mg, which is solid, will react with 2HCl aqueous to produce MgCl2, which is aqueous, and hydrogen gas, H2. So this is the chemical equation. Let's now write the masses of the reactants. So the mass of magnesium is equal to 4.80 grams, whereas that of HCl is 7.3. In questions like these, you have to be working with the number of moles and not the masses. Pay attention to this point. We are also given the relative atomic masses. So the relative atomic mass of magnesium is equal to 24 and that of HCl is 36.5. How did we know that it's 36.5? So we will add up the relative atomic mass of hydrogen and that of chlorine. 1 plus 35.5 is 36.5. Now, because we have the mass and the relative atomic mass, we can calculate the number of moles. According to this equation, to find the number of moles, we will divide the mass by the relative atomic mass. So what's the number of moles of magnesium and HCl? Excellent. The number of moles of magnesium is 4.8 divided by 24, which is 0.2. And the number of moles of HCl will be 7.3 divided by 36.5, and this is 0.2. If we compare these two numbers of moles, we will find that they are equal. However, you have to pay attention to the stoichiometric coefficients. So now we have to find the ratio of each reactant. How to find the ratio? We will divide the number of moles by the stoichiometric coefficient. The stoichiometric coefficient is the coefficient used to balance the chemical equation. So that of magnesium is 1, here we have 1, and that of HCl is 2. So the ratio will be 0.2 divided by 1, which is equal to 0.2, and that of HCl will be 0.2 divided by 2, and this is 0.1. Now compare the ratio. Which ratio is smaller? Excellent. The ratio of HCl is smaller, and thus HCl is the limiting reactant or the limiting reagent, and magnesium is in excess. You can also think about it in this way. From the balanced equation, we can conclude that 1 mole of magnesium will react with 2 moles of HCl. Therefore, 0.2 moles of magnesium will need double the amount of HCl to react completely, and this is 0.4. However, we only have 0.2, and thus HCl, hydrochloric acid, is the limiting reactant.